Okay. We already started talking about energy for exercises, how it is acquired in aerobic and anaerobic exercises, and we'll still talk more about this, but we need to reiterate this because this is just so important. So, obviously, in order to get the energy, this is from chemical perspective the redox chemical reactions. So we need to oxidize the fuels that we have. What is the fuel in case of our cells? In case of our cells, the fuel is, for example, glucose or fat. And we oxidize it in case of oxidative phosphorylation with oxygen. Yes. And this process is happening in the mitochondria. Otherwise, we also have a way to partially oxidize it in the in the process of glycolysis. So how to know from the perspective of the whole organism how much oxygen we use? This can be measured by the oxygen uptake. Yes. So oxygen uptake tell us how much oxygen we used as a whole organism. Also, it is quite important that when we would exceed our ability to get the oxygen into the muscles, we would switch into the way of getting the energy without the oxygen. Yes, so glycolysis. And in this case, what is important, and I did not yet told you, however, I suppose that most of you already know it, is that in case of the glycolysis, apart from the problem that not so much energy is produced, the other problem is that it leads to accumulation of the lactate. So exercising, okay. And generally, in case of the aerobic exercises, the levels of the lactate in the blood should remain small. Of course, it is not like that there would not be lactate at all. As I said at the very beginning, we would have always some mix of the oxidative phosphorylation and glycolysis. However, the rate, yes, so the relative amount of the energy acquired in the glycolysis would be far bigger in case of the anaerobic exercises. However, we also need to remember that the fuel is generally the same. Yes, so we have the glucose, that is the main fuel. We can also use some fats. And in case of the anaerobic, this fuel, as I said, is a glucose. Yes. So fats are generally are not used in the glycolysis. We need to have the glucose. Yes. Okay, we'll not delve into much detail about this. I suppose it's quite understandable. Okay. Okay. So what else can we measure? What else can we check to guess what does the organism do? So how much of the energy is produced via the glycolysis? How much energy is produced via oxidative phosphorylation? We can also measure how much carbon dioxide is produced. As we said, the production of the carbon dioxide is mainly related to to production of energy. Yes, so the carbon dioxide is mainly produced by the mitochondria in the oxidative phosphorylation. The more the carbon dioxide is produced, the more of the energy we had used. We had produced, to be more precise. About the amount of water produced in the metabolic process, of course, it is also produced, but it is far harder to measure because the metabolic processes are only partially responsible for water in our organism. Most of the water we just intake with some fluids that we get into our gastrointestinal tract. Okay, thank you.